This is Math 6, Lesson 6-4, Dividing Mixed Numbers. You may need to divide mixed numbers in measurements to make home repairs or to change a recipe. I know that when I have cooked, many times I've either had to multiply a recipe by something because I wanted to make more of it, or divide a recipe by something because I wanted to make less of it. So being able to work with fractions is very helpful because very few times in a recipe do you put in 2 tablespoons of something. It's normally like 1 3/4 of something, or a half a teaspoon, or a half a cup, or a third of a cup. So being able to work with fractions makes sure that my recipes come out tasty. I would hate to bake something and mess up the measurements and have it come out like a brick. So to estimate the quotients of 2 numbers, you should round each number to the nearest whole number and then divide. So a lot of times you can estimate your quotients of mixed numbers as well as we estimated our products of mixed numbers. We want to make sure that we estimate them to the nearest whole number and then divide. So if I took 7 2/5, 2/5 is less than a half, so that would be 7 divided by 1 3/7. 3 is less than half of 7, so that would be 7 divided by 1, so it's approximately 7. 14 and 9/16. 9 is over halfway through to 16, so that would round up to 15. Divided by 8/19. Well, 8 is not less, it's not half of 19, so that stays as 3, and 15 divided by 3 is 5, so this is approximately, because these are all approximate answers. 8 3/4. 3/4 is over halfway, so that would estimate to 9. Divided by 3 and 1/3. 1/3 is not over half, so that'd be divided by 3. So 9 divided by 3 is 3. We might come back to some of these numbers at the end of the lesson to see how close our estimates are to the actual answer. Now, to divide mixed numbers, again, we need to express each mixed number as an improper fraction. You cannot just divide the whole number parts and divide the fractional parts. It doesn't work that way. We must express each number as an improper fraction first. That's very, very, very important. Then you divide like usual, which means you multiply by the reciprocal. Okay, let's take a look at some problems. Divide and then write in simplest form. So 2.5 divided by 4/5. So the first thing I'm going to do is I'm going to change this to an improper fraction, but I'm going to keep it a division problem so that I make sure I do all my steps. So 2.5, 2 times 2 is 4, plus 1 is 5 halves, and I'm going to divide that by 4/5, which means I'm taking 5 halves and I'm multiplying it by 5/4. And you were really hoping those 5s would stay on opposite ends, but they did not. So we have 5 times 5 is 25, 2 times 4 is 8. 8 goes into 25 3 times, because 8 times 3 is 24. Okay, so it's 3 and 1/8. And if I was to look to estimate this, this would be about 3 divided by 1, which is about 3. Because if I was to estimate this, 2.5 rounds to 3, and 4/5 it rounds to 1, so it'd be about 3. So that's a pretty good estimate. Number 2 here, I'm going to take 8 and divide it by 2.5, so that's 8 over 1, divided by 2.5 is again 5 halves. So then we're going to take 8 over 1 and multiply it by 2/5. Please do not try to change your numbers into improper fractions and multiply by the reciprocal in one step. 95% of the time, something gets forgotten and the problem becomes wrong. It's better to show all the steps and get your problem correct than to skip steps and get your problem wrong. So show all your steps. I showed this step here, I showed this separate step here, and now I can multiply. 8 times 2 is 16, 5 times 1 is 5. 5 goes into 16 3 times, with 1/5 left over. So 3 and 1/5. Okay. Alrighty, let's take a look at number 6. 1 and 5/9 divided by 2 and 1/3. So I have to change both of these into improper fractions. 9 times 1 is 9, plus 5. 9 plus 5 is 14, so that becomes 14/9. Divided by, notice how I keep it a division problem until the very last step. 2 times 3 is 6, plus 1 is 7, this is 7/3. So now we keep the first fraction, multiply by the reciprocal. We call that keep, change, change. Keep the first, change the sign, change the other number. Okay, so we're multiplying by the reciprocal. So 14/9 times 3/7. Well, this one cross cancels nicely. 3 goes into itself once, goes into 9 3 times, 7 goes into itself once, it goes into 14 twice. If I multiply straight across the top, I get 2. If I multiply straight across the bottom, I get 3. So I get 2/3. So 1 and 5/9 divided by 2 and 1/3 is 2/3. Less than a whole, which makes sense, because I'm taking a smaller number and dividing it by a bigger number, so I should come up with a smaller number. Back to the algebra things again, when we have numbers and letters and all kinds of fun stuff. So if I have e.g., if you remember, a letter next to a letter is multiplication. So I threw a multiplication and some division in the same problem here. So we have e.g., e is 2 and 5/8, g is 1 and 3/4. So we're going to take 2 and 5/8 and multiply by 1 and 3/4. This time we're multiplying, we're not dividing. So we're simply just going to change them to improper fractions, and then cross-cancel if possible, and then multiply. 8 times 2 is 16. 16 plus 5 is 21. So 21/8 times 4 times 1 is 4, plus 3 is 7. 7/4. Oh, I wish I was dividing, because then this would cancel out so much nicer, but nothing cancels. 21 times 7. 7 times 1 is 7. 7 times 2 is 14. So 147. 8 times 4 is 32. 32 into 147. Well, think of it as being 30 into 150. I'm thinking it's going to go about 5 times would be a little bit too much, so I'm probably thinking 4. Let's see, 4 times 2 is 8, 4 times 3 is 12, so I'm going to borrow here. 17 minus 8 is 9, 3 minus 2 is 1, so it's 4 and 19/32. And there we go. Number 8 says E times F, so 2 and 5/8 times F, which is 2/3, divided by G, which is 1 and 3/4. So I'm going to change all of these to improper fractions first. So 2 and 5/8, 8 times 2 is 16, 16 plus 5 is 21, 21/8 times 2/3, divided by 4 times 1 is 4, plus 3 is 7, 7/4. So this would be 21/8 times 2/3 times 4/7. That's the one thing I do like about fractions, is you can multiply more than one of them at a time. So now I can sit here and I can cross-cancel. And you might say, but there's a lot of things I can cross-cancel. Yeah, there really is. I can say, oh, look, 3 goes into itself once, it goes into 21 7 times. This 7 goes into itself once, and it goes into this 7 one time. Yes, you can double cross-cancel. 2 goes into itself once, it goes into 8 4 times. 4 goes into itself once, it goes into 4 one time. So I've cross-canceled, and what do I end up with? 1 times 1 times 1, which is 1. 1 times 1 times 1, which is 1. My answer here is 1. When everything gets done, not everything canceled out. I get people go, everything canceled out. No, it didn't. Everything got canceled down to 1. And 1 times 1 times 1 is 1. So my answer here is 1. Much easier than multiplying 21 times 2 times 4, and then dividing that by 8 times 3 times 7. We love cross-canceling. Let's look at a word problem. Shalene wants to make cookies with 3½ cups of raisins distributed evenly or equally among 5 batches. What amount of raisins should she put into each batch? So in other words, she has a cookie recipe, and she has oatmeal cookies. She decides she wants to add raisins to her oatmeal cookies because she likes oatmeal raisin cookies. But she only has 3 1/3 cups of raisins, and she wants to equally distribute it in about 5 batches. She doesn't want to accidentally have, oh, look, the first 3 batches have lots of raisins, and batch 4 has a few raisins, and batch 5 has no raisins. She wants them equally distributed. So she needs to take her 5 batches of cookies and make sure that those 3 1/3 cups is equally distributed. So she needs to know, okay, how to divide 3 1/3 by 5. She needs to take her number of cookies, amount of raisins, I gotta say that right. She needs to take the amount of raisins she has and divide it by the number of batches she wants to make, so she knows how many raisins to put in each batch. So she has 3 1/3 cups. She wants to divide that equally among 5 batches of cookies. So 3 1/3 will change to an improper fraction. 3 times 3 is 9, plus 1 is 10. 10/3 divided by 5 over 1, which is 10/3 times 1/5. Notice how I work vertically so it's neater. Okay, so here we go here. I can cancel 5 goes itself once and it goes into 10 twice. So this becomes 2 times 1 is 2, 3 times 1 is 3. So she will need 2/3 of a cup in each batch of cookies. So if she puts 2/3 of a cup in each batch of cookies, the raisins will be evenly distributed between all her batches of cookies. And that is dividing mixed numbers.